2 cos squared x minus 1 minus cos x, correct? Now what's in the numerator? Monomial, binomial, trinomial? What's in the numerator? Trinomial. 3 terms, correct? The bottom's a binomial, the top is a trinomial. Could they ever cancel each other off currently, the way they are? No, trinomials have to match trinomials. But the top here is 2 cos squared x minus cos x minus 1, which I can do decomp to. Correct? I can rearrange that top, that numerator, and I can do decomp. More often than not, if people are stuck, it's because they don't notice the difference of squares, or decomp, or GCF. Other than that, you guys are pretty good. It's when you don't notice the factoring part of it. So then this, I can say 2 cos squared x minus 2 cos x plus 1 cos x minus 1 group. Take a 2 cos x out. You could replace it with m's, remember? That's fine. I get cos x minus 1. I take out a plus 1. I get cos x minus 1. And so I'm left with cos x minus 1 and 2 cos x plus 1. And I just show the work off to the side. Because if I have to factor this in steps, this is going to be the longest proof known to man, correct? Because you'd have to continue to write this whole right-hand side down, 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 down if you were actually doing decomp. So you can do the decomp off to the side, and the top becomes the numerator, cos x minus 1, 2 cos x plus 1. What can I do to the denominator? Oh, look, we have a cos x minus 1 and a cos x minus 1. Life is looking good. That needs to get out of my life. What can we do? Yeah, take out a GCF of sine. It's 2 terms. I know it looks like it's more because of the brackets, but I think the brackets prove the point, because you guys think it's brackets, you can cancel. So I can take a sine x out of this term and this term, because that's 2 terms because there's a plus sign between. So if I take out a sine x, I'm left with 2 cos x plus what? Yeah, sine x divided by sine x is a 1. Don't forget that. And then these cancel. And then we have happiness. Why? They're very close to matching, right? Now look, if I have to state my NPVs, my restrictions, my non-permissible values, they're going to be for where sine x can't equal 0, because that's in a denominator, and 2 cos x plus 1 can't equal 0. So cos x can't equal negative a half. And you have to state all those spots, right? Wherever there's a denominator. Right now my grandma Hamel doesn't know those match, so I have to keep going. Cos x minus 1 over sine x. Now would she say they match? Yes. So LS equals RS. Don't forget this, you'd lose 0.5. It's the easiest 0.5 to get, also the easiest 0.5 to lose. Okay? Then we're going to look at example 8. Like I said, I just wanted you to try them. If you got stuck, no big deal. I expected you to get stuck. So, first thing I have to do, left side, right side, and write them in here. So I get sine x, cos x, minus sine x. Oh, wow, I really went ahead. That's so disappointing. It's a really nice example. Okay, cool. We'll go to one that's not nearly as nice. Much more excessive. Left side. Right side. Sine 2x. So much replacements. Minus cos x over 4 sine squared x. And then sine squared x. Like, which one's more complicated? I don't know. They're both kind of sucky. I'm actually going to do the right-hand side first because I see that I can take a cos x out and it makes me happy. And the left side looks a little complex. So I'm like, not today. I'm going to deal with you in a few minutes. What can I do to the right-hand side? What can I do to the numerator? What is that? A binomial, monomial, trinomial? Which one is it? Binomial, because it's 1, 2 terms, correct? What can I take out? Yeah, a cos. So if I take out a cos x, I'm left with sine squared x times cos x, take out a cos x is sine squared x. Plus cos cubed x, take out a cos x is cos squared x. Over 2 sine x plus 1. Does anyone see something else that can happen? Yeah. Yeah, so on the formula sheet, Pythagorean theorem identity, the very top one, it says sine squared x plus cos squared x equals 1. So this whole thing can turn to a 1. And I'm left with cos x all over 2 sine x plus 1. That's where I know I'm headed, correct? Then I go to complexy, which is the left-hand side. The good thing is it's sine 2x. That should make you happy. Why? There's only one replacement. Not a lot of brain matter. You just have to sub it in. Okay? After that, maybe more brain matter, but to fill in, not very much. So sine 2x is 2 sine x cos x minus cos x. And the denominator, most people miss this. I'm not gonna lie. 98% of the time you're stuck, you're missing a difference of squares. 98% of the time. And you will see this. When we practice questions, you'll be like, I'm stuck. And then I'm like, it's a, and then you're like, difference of squares. Every time. Like 2% of the time you made an oopsie somewhere along the line. 98% of the time you're missing a difference of squares. So 4 sine squared x minus 1. If I looked at it as 4m squared minus 1, this is just a side caveat. I'm not going to do that. What would this be? What's the square root of 4m squared? 2m goes in the front of each bracket. What's the square root of 1? 1. You guys also mess up more on a difference of squares if one of the terms is a 1, because you forget it's a perfect square. If it was like 4 sine squared x minus 9, you'll spot it more, because 4 and 9 seem more perfect square to you than 1 does. 1s are often missed. In math 10, when you factor them, in math 11, when you do rationals and you have to be able to do difference of squares, they're often missed. So plus 1 minus 1, right? Opposite signs. Why do we use opposite signs? There's also conjugates. Why do we use conjugates? What does the conjugate get rid of? The middle term. Does this one have a middle term when it's a difference of squares? No, a difference of squares is actually one of the best labeled things. It's not like Pythagorean theorem. Someone named Pythagorean decided to give you a theorem. That's what that is. Difference of squares is a difference minus sign of squares. Like, thank you, person who defined that one. Difference of 2 squares. Right? Okay. So we get 2 sine x plus 1, 2 sine x minus 1, and this should be making us a little happy because that is not a minus. That didn't make me happy. 2 sine x minus 1. Why should this be making me a little happy? There are 2 sides to every proof, correct? We're starting to see anything similar. What? This bad boy has to stay, right? The rest can get out of my life, but that, no matter what, we want to keep because it's matching the other side, right? Anyone see anything else I can do? Yeah. Take a cos x out of the top. Oh my goodness, it's starting to look like this one. Life is getting better. We're getting happier. Things are looking similar. It's not just chaos. 2 sine x take out of cos x is 2 sine x. Minus cos x take out of cos x is 1. Oh my gosh, it matches the thing that needs to go away. My life seems really great right now. I seem happy. I can see the forest. I can see so many happy things. So Grandma Hamill's happy. She's not yet totally happy because they don't fully match, but are they very close? Yeah. See, this is the TSN turning point in a proof. It's when you start seeing that you're actually going to get the answer right. You're like, yeah, But then, like, literally a step from previous, you're like, I don't know what to do. So you go from, like, sheer, like, to, like, you know, in one step. Yeah. Yeah, you go from, like, I can't do this. And then all of a sudden things cancel off, and you're like, I got this. I am, like, I rock. I am the best proofinator on the planet. And then like a step earlier, you're like, I suck. I can't even do math. Why am I here? That's how proofs work. You're welcome. They're good. All right. So they match. Cos x over 2 sine x plus 1. It's really like an emotional roller coaster proof. Left side equals right side. And you just hope that your car stays on the tracks, you know? You just fall. Okay, the next one. Promise you they will get easier as we practice more to start seeing patterns, right? Do I expect that you would have walked away to being able to do every single one of these perfectly by today? No, I expect you to struggle. If you did do them all, great. Woohoo. I expected none of you to get them. So there's where I was at. Okay. Left side, right side. Make sure you're rewriting the first step. Cos x plus cos x tan squared x. I told you guys the people who do really good at proofs and this unit know what's on their formula sheet. Is that true? Is that what I told you? If you know what's on your formula sheet, if you're searching, it's not good. Because you don't know that sine squared x plus cos squared x equals 1. So you're not getting that 1 up there, right? You're searching for life, trying to find things. If you know what's on there, you'll do way better. You can look still and confirm you're right, but you need to know what formulas are there. What can I do to the left side? Yeah. Take out a cos. Remember, difference of squares and GCFs are usually the problem. Cos x take out a cos x is 1 plus tan squared x. If you know what's on your formula sheet, you're like TSN turning points happening right now. You're getting super excited. You're happy. You're really, really happy. Why? Does anyone know what 1 plus tan squared x is? You know it's a formula on your formula sheet. You know to go to it. You know to pull off secant squared, and life is getting better. You don't know that formula is on your formula sheet. You are replacing tan squared with sine squared x over cos squared x. You're making a common denominator, then you're canceling. It's just awful. It gets real awful. But if you know that 1 plus tan squared x is secant squared x, your life is a lot easier, right? So it is the people who know what is on that formula sheet that's lives will be created much quicker. Greater times. So, secant squared x. I know I need to keep one of those bad boys. I need to get the other one to get out of my life. We agree? What is secant squared the same as? 1 over cos squared. Remember, you can take the singles and make them squared, right? Remember that? All these top formulas on my formula sheet, I can replace with squares. We agree? So if I have secant squared, that's just 1 over cos squared. I can do that. I can make the singles be squares. I can't make the squares be singles. These can't become singles. So if I ever have singles, I can only use these. But if I have squares, I can use the whole page. Okay? So, secant squared x is 1 over cos squared x. Monomial, monomial, correct? So, I can cancel off a cos, and I'm left with 1 over cos. So now I can either change the left side to secant, or change the secant to 1 over cos. Does it matter which route I go? It matters if you only change one of them. If you change both of them, you're back to neither of them matching. So I'm going to be a rebel, because most people probably change that to secant. I'm going to change this to 1 over cos x. Grandma Hamill's happy, we move on. Left side equals right side. There's so many of you that I will say, you have to have the table with the question directly in the very front part, right? That's how I check my proof. And then you guys will start doctoring it and put it in. I'm like, ah, that's a 0. So if your first step is to not rewrite left side, right side, it's really easy to mark. It's also very sad. You get a 0. You proved something totally different than what I asked you to prove. Okay? So please don't do that. It's not good. I don't like it. It makes me really sad. It's really easy, really sad. It's quite a combo. It's a roller coaster of emotions. All right. Let's try this out. LSRS. Sine squared x minus cos squared x over sine x plus cos x. This question is done in 2 steps if you spot the catch. So what I get a lot of people doing is they say cos squared x minus sine squared x, and then they're like, oh, those are just backwards. So to take a negative 1 out, I can replace it with negative cos 2x. Does that help us in any way? No. What can we do? The top is a difference of squares. Sine squared x minus cos squared x is actually, the square root of sine squared x is sine x, goes in the front of each bracket. The square root of cos squared x is cos x. And then I get a plus, minus, over my denominator. Oh my goodness. The numerator has something that's the same. This and this match. So I need that to go. Literally how you feel in a proof. You guys just being quiet. That's exactly what happens. You like find something and then it matches and you're like, what? This is amazing. I'm so smart. Yeah, true. See, proofs make you feel good or bad. There's no in between. I hope it's good. Often if you're on your third page of the proof, you've done something wrong. Like you're on like step 77. You're not doing something right. Okay? Now we get to go to the one I liked. Here we are. Okay. What can I do to the left side? Take out a sine x in the numerator. And then I'm left with sine x cos x. Take out a sine x is cos x. Minus sine x, so I have a sine x is minus 1. What is the denominator? Look, nothing matches. I was going to say, look, nothing does. It's actually disappointing. It's a difference of squares. What's the square root of cos x? Remember, when it's two factors, or not two factors, when it's two terms with a minus sign in between, always look for a difference of squares. The square root of cos squared x is cos x, so that goes to the front of each bracket, because it's the first term. The square root of 1 is 1 minus plus, boom. And then you feel defeated because you still don't match. So this is like, you had to do some steps to get to like example 6. Example 6 looked like this at the beginning. What do we have to do if we're stuck? If we have all sines, all coses, but we have a 1 plus sine or a 1 plus cos or a 1 minus sine or a 1 minus cos, yeah. The conjugate. So I could do it here and extend this, but I'm kind of lazy and I don't want to have to like put an arrow over, so I'm going to work on the right-hand side now. But you could work on the left-hand side and multiply it by cos x minus 1, right? You'd be totally fine. I'm going to do it onto this one. I'm going to go 1 plus cos x. The problem lies in the people who do conjugates to both sides. You're just undoing one and undoing another, and then you're just getting further away. Now, what did I tell you to do with conjugates? You want to multiply the conjugates and not multiply the ones that are not conjugates. Why? Let's look here. Look. Cos x plus 1. 1 plus cos x. Those are the same thing. They're just a different order, right? Still positive cos x, positive 1. So I want that to stay. We agree? I need the sine x to get out. If I distribute the sine x in, can I get it out really quickly? No. So when you multiply by conjugates, you always multiply the conjugates together, and the ones that are not conjugates, you don't. And you're going to want to. So I would leave myself a little side note to remind myself of that. When multiplying by a conjugate, I multiply the conjugates together, and the ones that are not conjugates, I leave apart. Because I want this to stay, and I want the sine x to go. So in the numerator, I'm going to get 1 times 1, which is 1, plus cos x, minus cos x, minus cos squared x. These cancel. And I'm left with sine x. Now, the reason why you multiplied by, the reason why you multiplied by the conjugate is to be able to use the Pythagorean theorem formulas, right? The reason why you multiply by the conjugate is you can use these three, right here. That's the point. So I have 1 minus cos squared x. 1 minus cos squared x is the same as what? 1 minus cos squared x. Sine squared x. So I'm going to get a sine squared x in the numerator. And then a sine x and a 1 plus cos x. Now the sine squared x is a monomial. The sine x is a monomial, so I can cancel them. If this sine x had anything attached to it, I'd be stuck. That's monomial, monomial. So this one can cancel off that. And oh my goodness, I just have to rearrange the 1 plus cos x to cos x plus 1. And rewrite it. Now let's equals RS. Number 12. I want you guys to try it again if you haven't tried it or if you got stuck. Hint, the top is a difference of squares on the left, the bottom is decom. Try it out. Because sometimes you get it right illegally. Sometimes your mathematics is not sound. You break math. You're like, see, it worked. And I'm like, ugh, something not real happened in the middle. So, it's always good if you do it a different way. Doesn't mean it's wrong, but always call me over and let me check if you broke math or you just did it a different way. Because doing it a different way is totally fine. Okay? If it didn't break math. So, the top is a difference of squares. So I'm going to get 1 minus sine x, 1 plus sine x. And the key thing about difference of squares is that, and you were taught this in grade 10 and 11, whatever comes first has to come first in the bracket. Whatever comes last has to come last in the bracket, right? Like you can't go sine x minus 1, sine x plus 1 because you like it better. All right? If you want them the other way, you'd have to take a negative 1 out, and then you'd have sine squared x minus 1, and then you could write them in that format if you wanted to. All right? The bottom is really awesome, isn't it? But we have negative 3 sine squared x plus 2 sine x plus 1. So multiplies to give me negative 3 and adds to give me 2. So I get plus 3 sine x minus 1 sine x plus 1. Group. Plus sign in between. And I can take a negative 3 sine x out. And then I'm left with sine x minus 1. Take out negative 1 sine x minus 1. And then I get negative 3 sine x minus 1 and sine x minus 1. Okay, everyone's paying attention because there is a little trick to this one, hence why it's example 12. You know what I mean? So I'm going to get negative 3 sine x minus 1 and then sine x minus 1. Okay, everyone's looking up here. Look here. So I don't lose you. There you go, Lucas. Okay, so people think that 1 minus sine x and sine x minus 1 are the same. They're not, because if I rearrange it, I would have positive 1 minus sine x, and then I would have negative 1 plus sine x. Yeah? So they're the exact same, but wrong signs. True? Exact same, wrong signs. How do I make right signs? What could I do? Take out a negative 1. So if ever they're the exact same terms but wrong signs, I take a negative 1 out of one of them. Don't take it out of both, or you just adjust the signs for both of them and you'll be back in the same boat. Okay? So let's say I take the negative 1 out of the top. It doesn't really matter. If I take a negative 1 out, I'm left with negative 1 plus sine x. And it only comes out of one bracket. It doesn't come out of both. It doesn't change this one. Right? Because if I distribute this back in, it would change to this one, and that one would have stayed the same. It didn't affect it, right? Okay, cool. Then on the bottom, I have negative 3 sine x minus 1. And I could rearrange this if I so choose, right? I could write this as negative 1 plus sine x. Now do those two match? Yeah? Cool. Now they're gone. Now I look up here and I say 1 plus sine x. Yay, 1 plus sine x. Woo! 1 plus 3 sine x. What? No. They're so close, but so wrong. Okay. Positive 1 plus 3 sine x, negative 3 sine x minus 1. They're the exact same, but what? Opposite signs, correct? Negative 3 sine, positive 3 sine, negative 1, positive 1. How do I fix that problem? Take out a negative 1. Okay, so I'm going to have negative 1 bracket 1 plus sine x. That stayed the same. And on the bottom, I take a negative 1 out, and I'm left with positive 3 sine x plus 1. Do these cancel? Which I want them to do. They're gone. And then on the top, I have 1 plus sine x, 3 sine x plus 1. My grandma would not say those match. First off, even if the ones weren't there. She would say they don't match. So I would rearrange those, correct? I could rearrange this one, or I could rearrange that one. It doesn't matter. Because I take the sign that's in front of the term. They're both positive anyways. So I'm going to get 1 plus sine x over 1 plus 3 sine x. So Ls equals Rs. Does that make sense? Right terms, wrong signs, take a negative 1 out. Then they match. We agree? The way you could have solved this problem right off the bat is you could have taken a negative 1 out of this whole trinomial and factored it. And the negative 1 would be sitting out front. But who knew that? You don't know that going ahead of time. Sometimes you keep it in, sometimes you don't. Okay, grab out paper. I'm giving you proof you do, 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 proof you do. Tomorrow we move on to graphs. Your homework for trig is due Friday. Yeah. I'll protect you. Yeah. As long as you do it. Yeah, as long as you do it, I don't care where you do it.